second time, I only wrote secant instead of secant squared xy times the x and the y prime. Okay, now we're ready to go. So in the top, I'm going to take out the y, and I'll have a secant squared minus 1. In the bottom, I'm going to take out a negative x. If I do that, I'll have a positive secant squared xy. Then I'll have a minus 1. And what that does for me is it allows me to now, because it's this quantity times by x and times by the y, I can cancel those out. Simplifies to negative y over x. Okay, just about there. Okay, here, I want you to prove, or show, I could have used the word show, that the derivative of a power rule with rational exponents remember, rational just means that the number can be written as a fraction. So we're talking about fractional exponents here. Gives the same derivative as implicitly differentiating with integer exponents. Okay, this is one of those problems that the author loves. He loves to do things two ways and show that they come out the same. This is where we're at. So we're going to start with something with a rational exponent, like y equals x to the 7/4. That's an explicit relation because it's y equals. So we're going to do the derivative like we normally would. Then what we're going to do is rewrite this equation with integer exponents and do the derivative implicitly and show that they do come out the same. So let's just go with our regular old start the derivative explicitly. So the derivative of y goes to y prime. And this is just a power rule. The 7/4 comes down times x to the 1 less power. If I subtract 4 over 4, I'm going to get 3/4. Okay, so what we need to do now is rewrite this equation with integer exponents. So I'm going to start it as y equals x to the 7/4. So you have to ask yourself, I need to get this down to an integer, not a rational exponent. So what can I raise this to that will get me an integer here instead of this fraction? So I want the denominator to go away. And remember, when it's a power to a power, you multiply. Well, what I would want to multiply by, because I want to cancel out the 4, is 4 over 1. Because when I multiply, the 4s will cancel. That will leave me with x to the 7th. So I'm really just going to raise both sides of this equation to the 4th power. So if I raise that to the 4th, I have to raise this side to the 4th. And simplifying that, I get y to the 4th equals x to the 7th. Because the 4's cancel, 7 times 1 is 7. Now I have integer exponents, but I don't have a y equals. I've got a y to the 4th equals. So this is an explicit relation, or excuse me, implicit relation. So we'll follow our implicit differentiation rules. And once I do derivative here, it's going to take a lot of work, and I want to make it look like this one over here. They have to come out the same. So we just go through and do derivatives normally, and then when I do a y term, I multiply by the y prime. So this is a power rule. So 4y cubed times y prime. Here I get 7x to the 6th. Solving for y prime, I'm going to divide by 4y cubed. Divide by 4y cubed. So y prime equals 7x to the 6th over 4y cubed. Well, that doesn't look anything like this answer back here. The reason it doesn't is this one has x's and y's. This one only has x's. So what I need to do is get all x's over here. So I need to make a substitution for y. Well, I started out with the equation where y equals x to the 7/4. So I am allowed to substitute what y is equal to in here. So I'm going to take y equals x to the 7/4 and substitute that in for the y. So this is going here. And then I'm going to do some simplifying. And hopefully when I simplify, I get this answer over here. I better anyway. So we're going to keep the 7x to the 6th. 4, I want to substitute in for y and cube it. So that's x to the 7/4 cubed. All right. Keep going and give myself some room. 7x to the 6th over 4. I have to multiply exponents. You can make that 3 over 1. So you can multiply numerators and denominators. So that becomes x to the 21/4. And now, because I've got a whole number here and a fraction here, it's not so easy to just cancel. But the rule is when you're dividing, you subtract exponents. So I've got 7x to the 6 minus 21/4 over 4. So all I did was combine these, and I combined them by subtracting exponents. Okay. So if I make this, if that's over 1, that will be 24/4. Multiplying by hitting it with a 1 of 4 to get a common denominator, that'll be 24/4. So 24 minus 21 is 3. So that's 7x to the 3/4 all over 4. And that's exactly the same thing that I had back here. I just have it all over 4 instead of pulled out in front, but that's essentially the same thing. So there you go. Oh, not quite done yet. Last one now. This is number 25 from your book. Okay, 25. Circle problem. Consider the circle x squared plus y squared equals 100. You have to know this is a circle. The radius is 10. Show that negative 6, 8 is on the graph. Evaluate dy dx, that's just y prime. At the point negative 6, 8, explain why your answer is reasonable. And we're not doing the parametric. Oh, maybe. Oh, I don't know. Maybe. Okay. Here we go. X squared plus y squared equals 100. If I just did a quick sketch of that, it's a circle that goes out to 10. Centered at the origin. Okay, the first thing it asked you to do was it said show that negative 6, 8 is on the circle. Well, all that is plug in for the x and the y and show that when you do the math here, it does come out 100. So negative 6 squared plus 8 squared should equal 100. Well, that's 36 plus 64. 100 equals 100. Okay, so negative 6, 8 is about here on the circle. Part B is asking you to find dy dx. That's just y prime, same thing. And then substitute in the negative 6, 8 and show that your answer is reasonable. Okay, so we'll do the reasonable part later. So we want to find y prime. So we'll start here. I'll rewrite it again. X squared plus y squared equals 100. We have to do this implicitly because it's not y equals. So 2x plus 2y, y prime, equals 0. Solving for y prime, we're going to subtract 2x. 2y, y prime, equals negative 2x. Divide by 2y. Y prime equals a negative x over y. And then it said substitute your point in and explain why the answer is reasonable. Well, if I do y prime at negative 6, 8, so that's putting in a negative 6 for the x and an 8 for the y. So I've got the opposite of negative 6. Divide by 8. That's 6/8. That's 3/4. Well, think about what does this number represent. When I plug a number into a derivative, what is that giving me? If you remember, a value of a derivative is giving you a rate of change. It's the slope of the tangent line. And I got a positive 3/4. Well, I'm not on graph paper here, but at least the fact I can see that it is a positive slope, so is close enough, I guess. But they just want you to show that if you're on graph paper, that if you did a slope of rise 3, run 4, it will be a nice tangent line at that point. It won't intersect the circle twice. And we're not doing part C. Okay, that's all I have. Your assignment. Oh, I didn't write down. I have no idea what the assignment is. I'm going to have to let you know in class. Sorry, I don't have it.